show you all our spin detector. This was developed by the Big Bang Band, and this is an excellent activity because it's actually a hands-on observational activity, and it's a time-consuming one really, but we found that it really is worth it because the kids do enjoy it and they do really seem to get something out of it. I'm just going to hold this blanket up because I don't have ideal setting here for showing you this, but this is what it is we're talking about. So I wanted to make sure that you could see the grid itself. This is a modified version. I'll tell you a little something about what this, how this is used and why we designed it this way. And I'm going to zoom up and let you see that. Okay, so what you see here is a grid, and it's designed to be set up so that the person is sitting in such a way that each square is 5 degrees by 5 degrees of sky. And you can see on the side that there's numbers. We've got 5, 10, 15, 5, 10, 15. And this isn't used for the young children per se, but it can be used for the more advanced lessons. So now I want to talk about the other things that go along with the grid in this activity. You'll see we have a clock, and the clock is used to document the time passing, because the point of this observation, I might as well tell you now, is so that the people who do the activity can witness for themselves that the sky appears to be moving, and then of course the lesson is really about the rotation of the Earth. So we have a clock. You can use any clock, you can even use a watch if that's all you have, but I like to have the clock so that people can see the time for themselves. It makes it easier with the group. I have a little clipboard with the paper that the record is made onto, and I'll bring that up so you can see it. And we have a little clip-on red light. Well, I modified this so that it would be a red light, so it can clip on the clipboard. We have a table. The one we actually use can slant a little bit, which is ideal. A chair or a stool. And I use the little red lantern on the table in general. That helps to be able to see the paper. I keep some chalk. Generally when I do this, I'm doing it in a playground. And because you're actually recording the placement of objects through the grid, it is really important that everything stays in the same place. So once I have things set up, then I mark the placement of the legs of the stand and of the chair itself. And that's because I've taken pains to set it up so that the chair, when someone is sitting in it, is at the right distance so that the grid itself is 15 by 15 degrees. And the original sky grid, or the original spin detector, was actually 30 degrees by 30 degrees. And that actually is really good for prolonged observations, and it's fine for older children or adults, young adults. But we found with the little children, 30 degrees area was a lot of squares for them to count and to figure out exactly where it is they're seeing that bright star or that moon. So when you set it up, you're setting this up obviously so that they can see something that they can track. So you'll want to have them choose a bright star, or like I said, the moon, and older children can do more than one star. But I should mention that obviously it will work the best when you point it to the east or the south or the west, where you can really see that sky motion. You can see the motion to the north, but it's not as obvious. It doesn't seem to move as fast. And this is set up so that it will measure the roughly 5 degrees that the sky moves in about 20 minutes, since it's 15 degrees an hour. So now what I want to do, I'm kind of giving the basics of it, is I want to show you what the paper looks like. You will have a copy of this paper there at the observatory, but in case for some reason you're seeing this, you can just get the idea of what it is that you could just make on your own if you needed to. Detector worksheet, and this was made when it was still 30 degrees by 30 degrees, and you can see it has, I'm going to pause this and try to focus it for you. That's good. So the grid is 30 degrees by 30 degrees, and there's a space to write time number 1 and time number 2. And at the bottom there are some basic directions and an explanation for the apparent motion that they're seeing, so that when they go home they can look at it again. And then it can be used in conjunction with another form or other way of presenting this same information. This is more for older kids and adults, but this is a secondary lesson that can go along with this, which is how to measure the sky and what does 15 degrees mean. And so you could use something like this as well. So I'll tell you a little bit more about how to use this. Set up the stand, mark your chalk marks, set up the table and chair, measure it, make sure that where they're going to sit is 15 degrees. Then this, depending on what you're looking at in the sky, this can be adjusted so that you can put something worthwhile in the frame. And this also just comes apart, and this hole comes out of the stand at the bottom. This is elastic, and so you set it up with your chalk marks, and then when I'm doing this at the schools, I'm generally working with a line of children, like about 12 or 15 at a time. I'm finding this is hindering to have that big of a group, because what has to happen is the child sits in the chair and marks on the grid where they're seeing the object in this grid. They mark it here, and then they write the time, and then they go away, and then they come back again in about 10 or 15 minutes and do a second mark. I'll have them maybe draw a circle and then an X so that they can tell the difference. Kids get creative with that. And then they write time number 1 and time number 2, and then they can see when they've come back that it's not in the same place it was before, and we can talk a little bit about why is that? Is it really moving? Oh no, it's the sky it's the earth that's moving, and just a little bit of motion, body language along with that, and it becomes really obvious that they see, oh yes, it has moved, and even young children kind of get it. It's really kind of fun. And I was going to say something else about it. About the line. The kids, what they end up doing in a line is that they'll sit in the chair and make the drawing, and then go back to the end of the line and come through a second time. And with that many kids, it works out about right. It is cumbersome. It is not. It's not the best way to do it, unfortunately. But I would like to have 2 of these and be able to have half of the length of the line. We still do the project, even though it is cumbersome to do with a group that you're trying to get through quickly, because they do really seem to get something out of it, and they like it. They sit down and they really like to have something they get to do, and they take it home with them. I have also done this activity with a group of kids in a non-structured setting where they can come and go as they please. I've done this at public nights, and I've also done it in like a camp out for youth, and that works really good because the children don't stand in line. They come and go as they please, and they can come back and do it repeatedly on the same piece of paper, and it's relaxed, and that is the preferable way to do it. And then there's some tips that I have about how to get the children to get the best results. And what you want to have them do first off is, remind them not to move the chair. And if they do move it, you want to move the chair back to the markings that you've made. And I have them sit up as straight as they can, because I find that is the easiest way to position to reproduce. So when they come back, if they're not sitting the same way, the results won't be accurate and could be totally off. But with a little bit of attention paid to sitting up nice and straight each time, they can get pretty consistent results. And young children just need to look with both eyes open and do the best they can. As they get a little bit older, say around 7, they're getting where they can close one eye, and I find that the results are more consistent if you close one eye. And so with older children, I have them close one eye, and then when they write down the time, I have them also write an R or L for which eye they were using to look with. And that way when they come back, believe it or not, they might forget, they can use the same eye. And sometimes with the older kids, just to illustrate my point, I have them just sit there, sit up nice and straight, and now look with one eye, and now close that eye and open the other eye, and they can see that shift, right, just the distance between their two eyes, looking up at this, they can see it move. And let's see, with the younger children, especially really young children, this activity allows them to, a simple lesson in just observing the motion. They see, oh wow, it's moving, things seem to move. And you can tell them that it's because the earth is turning. But then the older the child gets, the more you can incorporate other things, especially the stuff about, how many degrees did it move, and talk about how, the sun, and actually with all the kids, you can talk about how it looks like the sun is moving. You see the sun rise, you see the sun set, and why is that? We see the moon move. It looks like it's moving. And and also, a lot of times I'll tell them that they could do the same thing at home without a sky grid by using a pole or a tree in their neighborhood and going out and having, you've probably heard this lesson where you stand so that the moon or the sun is lined up over a pole or a tree, and then you come back a little while later and it's moved when you stand in the same exact spot. And I think that is everything about using the spin detector. What I want to do after this is tonight I'm going to take the spin detector out and set it up so that you can see the moon through it. We've got a full moon tonight, and you can see for yourself what the motion looks like. And naturally, I did remember something I forgot. I wanted to show you an example of one that's already been done. This is one that I did when I was experimenting with it myself. Here we see at 7:25, my first drawing in the upper box. This is the moon at 7:25, and then the second time was 8:28, and it's moved to here. So that's about 5, 10, a little less than 15 degrees in an hour, and that's expected with the moon because it doesn't quite move 15 degrees an hour because it's actually physically moving the opposite direction of the motion that we're observing. And then the bottom image, I did it again. The first time was 8:34, and the second time was 9:26. And here's the moon in the first drawing, and it's kind of hard to see, but there is the moon in the second drawing. And for the fun of it, I sketched the landscape in, and you can see how many degrees the landscape, or I should say the horizon is. And then I have another one, I'll show you. Also the moon, and the first one was drawn at 8:02, and the second one at 8:22, so that's 20 minutes, and you can see that's just a little under 5 degrees. The last example I happen to have around to show you is Serpens Cauda at 10:25. This is the first drawing that was made. And then at 10:40, so this is 15 minutes, here's my second drawing. This here was a mistake and that's crossed off, but these 3 dots are the same, is serpenticata, so you can see that it's moved down and it's also moved over. So it gives you a sense of the cross motion and, in this case, the downward motion, since it was heading downwards, whereas if it was pointed more east, it would have moved upwards. And I think that explains this one pretty good. So tonight I will let you see the moon for yourself. And one thing I did forget to mention is that in very dark settings, I do have to sometimes shine a flashlight at the grid so that it lights up enough to be able to see the white strands. But usually in my average usage, that's not a problem. And also I'll mention that you'll see that there's alternating white and dark green stripes on the edges of the grid. So basically each stripe represents 1 degree of space, except that it's kind of messed up at the corners. But that's just kind of something worth mentioning. Here we are. It's moonrise, just a little past. It's 6:21 by my clock. And you can take a look at where the moon is. I'll turn off the light for a second. Doesn't come in very good, I don't think, but make a note of that and we'll check it out in a minute. I'm making an estimation about the 30-degree angle. It's kind of hard to do with the camera, but it's closest to 30 degrees away. Well, to be in position so that the view covers 15 degrees of sky. Used to be 30 degrees, now it's 15 degrees. Okay. Okay, it's now 6:41, and this is how far this moon has moved. Seems to me it's not quite 5 degrees, which actually is what we expect with the moon. Maybe more like 4 degrees. And I wanted to say something about working with little kids. The moon, of course, is easy for everybody to see, but if you're working with a star or, say, a planet that you've got sighted in this, I'm going to turn this light off. Hopefully you can see my laser pointer, but I will, sometimes use my laser pointer to point at the object, and so that it's really clear to the child what it is they're trying to position in the grid so that they can draw it on their paper. I'm going to show you in a minute the pictures that I drew. I should look at it one more time so that I can remember where it's at. Okay, so that you can see what happens when you do this activity on your own. Try this. I'm going to show you my drawing, my charting, or whatever you want to call it. It's pretty dark, but you can see number 1 and number 2. They're both dots. And the times I wrote down, full moon. And so that's how it turned out. Let me shine that light on a little bit more. And I think, I can't think of anything else to say, so enjoy. Okay, now I've let another 20 minutes go by. I decided you might as well get to see another jump. What I've done is the second time I let the camera run for the full 20 minutes, and after I get done explaining all this to you, if you would like to, you can watch that full 20 minutes. I'm gonna just tag it on to the end of this training video so that you can actually see the motion of the Earth spinning combined with a little minus action of the fact that the moon is rotating around the Earth opposite the direction that it's spinning. So, if you'd like to watch that, go ahead, and I'm going to go ahead and mark my sheet and see what results look like. Okay, I'm showing you again my drawing, my recording from the grid. You can see I'm a little less than perfect, but I wanted to point out that the last time I showed my drawing, I had modified the grid
incompletely because I had only marked out 20 degrees. It was a 20-degree grid, and now I've corrected it, and you can see only 15 degrees of grid. I don't have the new spin detector sheet here, so I'm trying to work with one of the old ones on the new grid. But you can see time number 1, time number 2, and time number 3, and those are my results. Okay, and that's it.